I would like to introduce our speaker for the night. So Kellyn Gorman is a multi-platform advocate and engineer at Redgate, and she has been in the database industry for over 25 years as a multi-platform DBA. She previously did Oracle SME on Azure at Microsoft, where you said that you got the Microsoft Champion in 2019. Kellyn has authored 8 books so far. Just crazy. Numerous articles, white papers, respected for her technical content under her handle DBA Kevlar. I know I've been following her blog and other online stuff for many years. I just
I'm old.
think we're very, very lucky that Kellyn was able to come up and hang out with us tonight and speak. So let's give her a round of applause.
So I drove up from Portland and I am so glad it was not raining. How about the rest of you? Yeah. My name is Kellyn Gorman. I am also known as Kellyn Put-Von Gorman, Kellyn Put-Von. You will see my books under every name on Amazon possible. So don't be surprised if you can't find everything. That's because I've been here so long and I'm so old and I got married throughout all of it. So what kind of prompted this session other than Jeremy asking me to do it? I have been in the community for a long time, and after I had built out Oracle and Azure at Microsoft, I'd gone over and was helping the guys over at Google. They are all my ex-coworkers from Encatech and that. They were building out everything. Andy Colvin, who was the daddy of the DBA team from Encatech, I've been the mommy of the DBA team. Yes, they called us that. I'm sorry, it's a horrible thing. But he was doing the Exadatas. The rest of the team was doing Postgres. They were doing the migrations. And the PM over this, who you used to work for, right? You used to work for Kevin?
Which kind of
Kevin Jernigan?
Jernigan?
Thank you. He had said, Kellyn, would you do some benchmarking with AlloyDB Omni? We've got this new thing. We've taken AlloyDB, that was the past solution for Postgres that is running on Google. We've containerized it and you can run it anywhere, and we'd like you to run it on Azure first. I'm like, oh, you guys are, that's like fighting words. This is going to go bad. And they knew that I would do it because I have a tendency to think there's no rules for me, that I can just do whatever I want. So yes, I did. I took AlloyDB Omni and I put it on Azure. And then I got them to agree that I could do HammerDB with it. And then I could also do it on Google. And I was also the director of data and AI for Silk at that point. And one weird thing that is the fact about me, again, I don't think rules are needed. I still work for my old company too. I was working for Redgate. I had worked at a deal that I could do 30 hours as the director of data and AI in Silk when I left Microsoft. And I could do whatever else I wanted with my other 10 hours because I get bored easy. So I was working for Redgate. Redgate came over and said, we want all your hours. Will you come work for us? And I said, well, I am still needed at Silk. So now I still work part-time at Silk. So I'm still ongoing doing this kind of stuff. That's why you'll start hearing me talk about other things and it gets very confusing because I have totally confused LinkedIn. It has no idea where I'm working right now. So with this, I started doing this testing, but I also had to find out how did this stack up against other flavors of Postgres. They wanted to know. And as I started doing this, I found research with HammerDB that was published on Yugabyte, on CockroachDB, on other flavors of Postgres, that because when I walked into the room, it was pretty much all my ex-coworkers, either from Pythian or from Encatech. They're like, Kellyn, will you blog about this? And I'm like, sure, again, you're going to get me in trouble, aren't you? Yeah, let's do this. So I got to use the other benchmarks that were out there. So what is AlloyDB Omni? As we were talking about, they decoupled it from the past solution. It doesn't have the high-end storage that Google has underneath it with the hyperdisk and everything else. It is containerized. It is Google's way of doing stuff. And anybody who works with a lot of the cloud teams, especially when you work in Azure or if you work in Google, you find out that everybody's just kind of figuring it out as they go along. This thing was cobbled together. I mean, it was in its infancy. They were changing it as we go along. I download the new version. I'm like, why did all the bash scripts become tickle scripts? Why am I working in a dataplane.conf? Why is this now? I'm back into Postgres.conf. What are you guys doing out there? So it was constantly a moving target for me. They would virtualize on top of virtualize. They would add virtualization at the storage layer. So I'm like, how do I do apples to apples comparisons all the way through this? So there were a lot of additional challenges that I had to take into consideration as I was doing these HammerDB tests. The configuration on this, as I stated, I was doing AlloyDB Omni. They went through 15.4 through 15.7. As I was giving them feedback, there would be a new release the next day. Google moves fast. They move really fast with this. It was deployed inside a Docker container. They added virtualization at the storage layer as well, which added another challenge. The VMs I was using, I started out with E-Series VMs on Azure. Those are some of my favorite. They're the best for relational workloads. N-Series on Google. Those are the best ones for that. And then I would scale up from 16 because they wanted to know, could I get some better performance than what they were seeing as well? My history and where I'm most known for is on performance and optimization. When I was at Oracle, I built out the AWR warehouse, which was the centralized repository for performance data. I am known as a performance optimization specialist. That's where I work. So as I started working with this, they said, how much IO could we get with this as well, which was Silk's agenda, because they are a high IO solution. They actually take the NVMe from VMs and put that into a Kubernetes data pod, bring it all together to get high IO for a lot of these workloads. They wanted to see how much IO I could get as well. They were about 26 gig databases. I was using TPCC. I did use TPCH as well as I started going into the warehouse workloads, and this was kind of my baseline that I was starting with. With HammerDB, of course, first install, it was on a VM, no big deal, simple installation, straight on there, we were going. Second installation, they were like, well, now we're going to use Docker because we think Docker should be used everywhere. It was the biggest mess that you've ever seen in your life. The instructions didn't work. And I'm like, why have we virtualized something when we are already on a VM and it's the only thing running on it? So I just trashed their instructions and just installed it straight onto the VM. So I kind of went on my own at this point. The PMs, the engineers, they were happy because they were so busy at this point. It was just about time for Google Next. And they said, Kellyn, whatever you're doing, because I was like, I'm not a tickle person. I am definitely Bash. I'm just going to go back and rewrite this all in Bash. And they're like, go for it. So I kind of reverted back to some of my other tests. It also gave me a little bit sense of a happy, warm feeling that I was doing something that was more apples to apples. Because every time they would issue some of these changes for how they were deploying this, I was like, I don't know if we're going to get something that looks like apples to apples if you want to, write these blogs, because some of these blogs did go out on the Google site. They're under Bjorn Rost. You can see him out there. He's the PM over this he used to be Pythian. So we worked together at Pythian. So as I started going forward, it was pretty simple. You have to install the along with HammerDB on your VM, you need to install the PostgreSQL client for it to connect and configure that. It's straightforward. The links, in fact, I think I put it in one of these right down there at the bottom. This is the link if you're interested in doing this. Anybody can download the Docker container along with the instructions and get this from Google and put this on any VM you want. You can put this on any 16 vCPU, 8 vCPU machine, it'll run. I wouldn't do it on a 4 vCPU machine, but 8, you're fine. It will run, no problem at all. It's just a Docker container. Same thing with the actual HammerDB machine. I would put that on its own machine. You don't want it on the same machine. This can be challenging, especially if you're trying to do performance. You don't want to be competing with your own HammerDB installation and what it's running. So keep that in mind. I know we're doing our little hackathon later, but when we start talking about reality and seeing what kind of performance that you're getting off of your system, you don't want to be competing with that. The flavor of Postgres, like I said, this was AlloyDB Omni, but I also started going down the PostgreSQL. They wanted to also know, Google was like, how do we compete up against just standard Postgres? Are we in the ballpark? Are we actually performing well? Once I got this all done, the flavors that I was doing, I did PostgreSQL 16.6 and 17.2 around September to October timeframe. 17 came out right about late October, I think. And then I was doing the tests for Omni from February through July. So these are the time frames that I was working through these. The benchmark results, they were publications that were on my blog, on Silk's blog, on Google's blog. We put them everywhere as we started to kind of mature this as we were going in different places. One of the big challenges are, and you're going to see this in the end of this session, is when we got into scaling and how we looked at scaling. I did bring in multiple machines for partitioning as well as distributing this workload across multiple ones, because that was something that we started to notice as I started to try to scale. So the benchmark, most of you know what HammerDB is. It is open source. If you were to tell me how much history I had with it, was it worth it? There is a blog out on DBA Kevlar where it's pretty much filled with 4-letter words when I'm using it with Oracle. Last person who worked on that code is 2005 was Kyle Haley. It's old. It's old. I would not use it for Oracle at all. SQL Server, it's a mixed bag. You got people, and I'm sure Rick hears this too. Mike Fall loves it. David Klee hates it. You know, it just depends who you're talking to when it comes to SQL Server. But Postgres and MySQL, people love it. It works out great. And because I think those are open source communities, the code is kept up to date. I think that it does a better job, and that makes a huge difference. Like I said, Oracle, it's completely neglected. Doesn't matter if you're looking at, you know, the TPCC, which is the OLTP workloads, or if you're looking at the analytical part, warehouse side with the TPCH. I mean, those are meant to try to give you that performance, those benchmarks. The one thing that I always say about benchmarks, and somebody asked me about this today, is that it's not the same as the customer workload. The value that you get out of it, it's going to kind of give you this information that says, you know, hey, this is what I get in transactions per minute. You know, this is what you got. But what does that mean versus a real customer workload? It is going to be unique. I can grab, you know, I'm a Linux. I can grab FIO and get the actual IO information if I want it for my storage. I can find out the way that a system is going to run with just memstat and that. You've got to think about that. You got to think about, what is this really providing you? Is it a worthwhile investment of time? But I felt like it was for these tests, and you'll see what comes out of this. But the GUI, I've never really used. I've always used the CLI, and that's what you kind of see from my data that I pull back. It's multi-threaded, effective stress testing on it. And when you start looking at the bottleneck on it, always keep this in mind when you're doing optimization, is that I don't see that you can really optimize that much on TPCC. There's a lot of stuff out there that says, hey, you can make these changes and that changes. But especially as I've done benchmarking over the years, because again, I'm Oracle, we use something called SLOB, which is silly little Oracle benchmark, or we use something called Swing Bench. When we're doing these performance tests, we always know that we're going to hit that bottleneck, and we usually move the bottleneck around. We try to lift it up in different places. Or in hardware, we increase our hardware capabilities. If we got it on the database design, we can fix that. If it's the code, you fix the code. But you're moving that around, and this kind of is limited there, where you're just running this, and if you make changes to it, you're not really going to be able to do those apples to apples tests. So I installed it on a separate VM, put in the PostgreSQL extension on it, I checked it, verified. I did bash. I get really annoyed with the tickle, and it's because I'm just not a tickle person. That just annoys me. I'm very happy with my bash scripts, and I feel like I can replace people with bash. I know bash. It's just an easy place for me. And then did my perf runs. Every time that I did it, I do a change enhancement on the database, because I was optimizing the actual physical hardware and the database parameters. That was my goal. I do a clean cycle, I'd warm up the run, then do the performance run, measure it, keep the change or revert. I try to do one change only. And then I would do a new test, rinse and repeat. And that's how I did this over and over again as I started going through it. Now I'm doing pretty big loads, and you're going to see that. We talked about this: database configuration, database code, infrastructure. Those are those 3 areas that I'm going to be looping between when I'm doing an optimization. And when I was working with the real world performance group at Oracle, the thing that we knew is that nothing could be off the table, even if it was the application or the database or the network. You had to look at everything when you're trying to optimize it. And this really doesn't do that. You're just looking pretty clearly. I run this workload against it, and these are the numbers, and here you go. I can change parameters, or I can change hardware. That's really all that I have available to me. The first thing though, is that I was looking at recommended practice. When people build me my systems and when I was at Silk, a lot of times the engineers would do it and they'd hand it over to me. They're like, oh, Kellyn's a director. We don't want to waste your time with it. The first thing I'd find out, I'm like, who gave me a D series version 3 VM? No, this is not going to cut it. I'm not running it against this. You need to make sure you have the newest VMs. It's surprising how much, especially when you're in the cloud, that, we're up to the V6s now in the E series, and that those have the better network cards, especially when we get into the M series where we can actually, bundle those cards, those network cards, and I can get a lot more IO. Your VM decides all. So the VM decides how much IO I can get, not just my memory and my CPU. So I was looking at this very closely. So I had to go through this and make sure of this. And I would always look at the documentation and make sure something hadn't changed since I had left Microsoft. I had to check with this. I even checked with one of the SAP teams because they get the best machines. I'm letting you know that every single time. SAP runs databases hard, no matter if it's SAP HANA or Oracle that's running SAP. And I went out there and was like, you guys got the MV3s? I want to get a hold of one of those. I need that new network card in there. I want to see what I can get out of this. And I have network attached storage. And that's one of the things that we talk about too. I also look at how to perform these upgrades. Your VMs, they're easy to change, really easy. Your storage is not. So always think about that too. And that's when we start looking at here. T1 storage. If you're not doing tier 1 storage, of course, you're not going to be able to keep up with those wall writes. Your write-ahead log is going to really be impacted. So I had to look at that as well. I chose native storage to start with, and that means PV2 on Azure. I was just using standard storage on Google. If I was working on AWS, it probably would be, of course, my brain went totally blank right now. This is because I don't work in AWS. Tell me what storage I want in AWS, Jeremy. What?
You think of like the GB2 versus.
Yeah, just standard native storage because you're going to be limited. It's attached storage. It's going to be limited. Where network attached storage, you're going to have less limitations. You're only going to be limited by that NIC. So that's extremely important to me. Can I get better IO? So I had to look at that as well. Make sure you have a dedicated user. This sounds really weird, but I had people that were like, here you go, Kellyn. And they gave me the Postgres database and they'd installed it. Strange. So I had to redo everything. Native versus attached storage. This is even interesting when you have people talk about Postgres and it is a PaaS solution. If it is clustered, you're going to get better performance, but always look at the documentation to find out what the limitations are. We were just talking about the DSQL, the brand new database that was announced from AWS today at reInvent. And some of the limitations on it is very interesting. The quotas are very interesting. What it's capable of actually performing. The limitations, 100 gigs, that you have limits in it where it says if you do a select count from a table, it's probably going to time out. That's kind of a performance limitation for a lot of big databases. You want to know that you can do that. How's it going to work on any kind of reporting? Probably not. So PaaS solutions, keep in mind that looking at the limitation documentation is extremely crucial. And so the same thing goes when you're looking at infrastructure. Infrastructure absolutely is where you want to go when you're looking at a big database and something that needs to perform fast. Probably can't scale it up. To be infinitely scalable, most of these cloud vendors, there are limits put on every one of the individual resources, and you start to feel that. So as I'm going with this, I'm looking at those and realizing what those limits are because I'm just going to make fun of Azure because I can. Rick, you're supposed to laugh at me when I do that. So you'll hear things like hyperscale. Everybody know what that is when I say Azure and hyperscale? It's the version of Postgres that's built into Cosmos DB. Do you know how much it can do? Throughput? 300 megs per second per every 16 terabits. It's not a lot. It's not a lot. And that's coming from somebody like myself who is being told, oh, we'll take that Exadata database and we're just going to move it over to here. That's doing 37,000 megs per second. No, that's not going to happen. Not going to happen. So absolutely look at the database limitations because they may be using a term that sounds very fast, like hyperscale. It's not. It's not. So always look at those. And then when I was looking at infrastructure as a service, like I said, when we start talking about something, and I used to do this, I used to do it with A&F. with always on availability groups, application volume groups. Sorry, there are too many acronyms over there. AVGs, also with Silk and that, we can get between 20 and 30 gigabits per second. A lot faster. And so I can go from that versus when we're talking about attached storage, PV2, those limits, depending on the VM you're looking at, it can be anywhere from 200 megs per second. And I have people that are like, well, I got UltraDisk and I went and striped this all and I'm doing 20,000 megs per second. It's like, your VM only has a limit of 200 megs per second. It throttled you right back down. So those VMs are really important. Always look at your VM, no matter how much beautiful storage you built. If it can't do it, it's going to kill you. And that's with infrastructures and servers. When you do network attached, your network is your only limit, so you can get better performance. So what were my results? And hopefully you can read those all right. This is with PV2. This is on the E16DS V5. It is a 256 gigs of memory on it. It has a limit on it of 2,000 megs per second. It's all that it can do for attached. And these were the numbers out here. These are pretty low. This is it throttled down. It was about 800 megs per second is all it could get. I mean, these are not big numbers. I added Silk to it. 2 C nodes. This is the smallest I can do on my Silk. I mean, this is just 2 C nodes. There's 4 M nodes underneath. Think of it as a Kubernetes data pod with 2 VMs. And that's all that's underneath this. It's very, very tiny. Using that NVMe, but you can see the numbers went up quite a bit higher. So I'm seeing a lot better performance with this network attached. And I'm going, well, that's pretty good. 16 vCPU. That's some pretty good numbers off of it.
Hey, Kellyn,
Please.
I think a bunch of people here probably super familiar with PTCC.
Mm.
So do you want to just real quickly say what NWPM stands for? It's 2 numbers that you just said on the screen.
The transactions per minute. And then the no PM, you would ask me this today after I had done this, how long ago? And I've been in other lands and AI land and everything for, you may have to help me out with this.
Okay, the NOPM is new orders per minute.
Thank
Here,
you.
I'll give you the 5 second. This TPCC is and just historically, one of those is called making a new order.
So the TPCH is the
TPC.
warehouse.
I think TPCC is still a warehouse. They're both are. And it's like because it's
Transactional. Yeah, TPCC is it?
It's
Okay.
simulating it workout. Like that's what like people placing orders.
Got it. The tables for it.
Table.
Got it. Schema, what's in there?
That's
Yep.
the idea. Simulation of business and warehouse business.
Yep.
So
I'm good with that.
Yeah, there's these 5 transaction types. It's like new orders, processing payments, shipping. Those 5. And just historically, for whatever reason, the way they decided that they always report the results. Now it's just they're just hard-coded ratios. I think it's 45 for like 42% are supposed to be new orders. So, but that NOPM, that was what you always had as your headline. That was the thing that historically you always put at the top of your report that went out. And it's like a decade when this was like huge. Like everybody was in the magazines advertising their NOPMs.
And I have all this data zipped up from runs and everything and all the logs and that because it'll tell you I created all of these users. I now ran all these users. I ran these workloads. You could see them. And then you would run this and it will do this output. And you go in there and it just zipped it all up, says this is your output. This is what performance you got off of it.
And that's why the wording. So if you look at the wording there, it says 18,000 new orders from a total of 41,000 transactions. So it's just
Thank
kind
you.
of telling you, yeah, there were a total of 41,000 transactions, and then about 42% of them, 18,000 were the new order ones. And the reason it's telling you that is just because of, again, the history that just historically was the thing that you would advertise.
Jeremy, it's reflecting the mix of write and read and write.
And that's where my brain always goes. I'm an IO person. So I was like locked in on this number, the TPM. Please.
Are these, excuse me, qualitatively, these lower numbers, are they supposed to be good numbers? They're better. Are they good?
I was hoping to get up over 1 million. I always wanted over 1 million. So when I saw the first number at 41,000, I was like, oh, that hurts. You know, I wasn't happy with that. And I knew that Google wouldn't be happy with that as well. I also had found, I had discovered at this point, an article, and the links are on the very last page. The links to published data that had been done through Azure on Cosmos DB, also Yugabyte and Cockroach DB. So I knew what they were able to achieve. And I knew if I showed this to the guys that I used to work with, they'd be like, you got to do better. You got to do better. So I knew what I was up against too. For this test, I no longer have this database. Is that what you're asking? Yeah. Every time that, they would give me a new release, you'd have to blow everything away. And Silk also wasn't too crazy about the idea of letting a Silk data pod run for very long. When I start ramping this up, I mean, that's going to start getting expensive, that you've got it running up all the time. You can't, with Silk, these are made for high IO workloads. And when these are running and you can shut down the C nodes, you can't shut down the M nodes. So at a certain point, I get that email from the CEO going, Kellyn, are you almost done? So, yeah. But I do have all the data. I downloaded all the data, the logs and everything. Any other questions, or did we get everything with Jeremy's help and stuff? Cool. So this is where I went in the database. One of the things was, as I said, this was kind of in its infancy. The conf files were changing. They started out with a dataplane.conf, and I'm like researching. And to give you my history, I am multi-platform, but the last time I worked on this database platform, it was called Ingress. Yeah, I'm one of those people who go, well, I'll do it. So I had an education as I was going through this. How will I optimize this? How will I learn about this? And I come up to this and I'm like, I'm researching and I'm like, I can't find this dataplane.conf in any of my searches on Google, and this was a Google thing, by the way, but they weren't publishing it. So it took me forever. I'm like looking at the parameters inside the database. None of this stuff is in there. It's like blank. And it was because they had this thing called the dataplane.conf and I had to change it. But most of these, as I figured it out and everything, I started to find what made sense. And one of them was, of course, the cache side. Can I do more in memory? That means I'm not going to hit the IO until I actually need to. So I started sizing this out and ended up with this calculation. Effective cache size times RAM times 0.07. So 70% of the RAM. This was a good safe space. I knew I was utilizing the best amount of that memory there. So I set that up. My next was the working memory. What am I doing when I'm actually doing sorts and everything else inside the database? So the working memory times the total sort operations for all users equal the value. So I was able to come up with a number there, and I think it was 64 megs. I think that was the number that came up. That was the best number, the most optimal number for what I was doing. And then the maintenance work memory. I would come up and do this. And this is for anything that it's doing, like creating indexes and stuff. This helped when I was building the big warehouses, when I had to do 1,000 users and everything else. That takes a long time. And so you're waiting overnight for this because, again, I'm not doing small tests. I'm trying to do big tests. So by having that set up with the maintenance work memory, that worked out well. And I didn't have to worry about vacuums coming in. And we'll talk about vacuum in a second, too. Miscellaneous optimization, synchronous commit. Now, this one, you're going to hear a lot of mix on this for people. There are people that say, you need to have this on. It's not a real workload if you don't. But I started playing around with it. I found that I got a little bit of improvement if I just shut the thing off and said, forget it. But keep that in mind. It's not going to be how your production system is. Think about what you're setting this to. If you're going to set it to local, if you're going to set it off, if you're going to set it on, everything it's on by default. Checkpoint timeout, checkpoint completion target. You can optimize that one a little bit and get it so that it's only checkpointing when it needs to. This will help as well. And what I'm really trying to do is making sure that my writes are being done at the right times. So with you'll have synchronous commit on. I can't talk today. You end up with this writing to the data dictionary on disk at the right periods and not too often. You're not often enough, and you end up with it going to disk when it needs to. Also ended up installing the Linux tools on here. Put that in, it helps us. I like to have FIO as well. I wanted to see my IO. I wanted to see that I was getting the performance because I also knew that as a baseline for Silk, I'd run so many FIO tests, so many with slob and everything else, that silly little Oracle benchmark. I knew what I should expect for performance. So I also got all the Linux tools to support there so I could do that. And then I went in and optimized my CPU power. You can set frequency set governor to performance. This will mean that it's going to perform more optimally. And again, you might say, well, this may not be how my production system is. But the question is always, what is the goal of your test? And mine was to get the best numbers that I possibly could. Question.
Is that, do you find that to be useful across the, like the monitor?
As in, I could do it in Google and Azure.
And it works great.
Yes.
Okay.
Yeah. But of course, you're going to have to do it each time you do that. And if you're inside a container, of course, you have to do it on the container. You have to install it. It even got down to like, I like to use, I'm a Vi person, not even Vim, I'm Vi. And so I have to install Vim. I have to install it. I want those tools. And people look at me and go, Kellyn, can't you just use like Nano or something? No. Because otherwise I'm sitting there trying to use my keys on my keyboard and nothing is working and I'm hitting the wrong things and I get frustrated. So yeah, I installed everything that I wanted. I just had a little script that I would just throw out there and get it run the way I wanted. And this is the last of this with, after you set it up, you can look at the frequency info and make sure that it's set to governor is performance. Supported, yes. Active, yes. If it doesn't, this is that check. So you can make sure that it is turned on and that it is working. And this is our CPU power idle set enable all. This just makes sure that you have the checksums on here and the enabled so that you don't have to worry about the last step of this. If you don't have both of these, you don't actually have it turned on. So you need both of those. And then Boost. This is something new in Azure. It was already in Google Cloud that Boost capabilities were set up. Look at your VM, make sure that it has this, and you can just check this. This is the command for verifying it. But the policy performances are set up on Azure. I grabbed it immediately when I got this because this will just give me a little bit more performance. I will tell you, it has to be available. This is what's interesting. So when you run your tests, I would not run it during the business day. I would run it during the evenings. Nighttime, same thing. If they got a lot of batch loads, again, it has to be available. And if it's not available, you won't get it. So you may have to do a small test first just to make sure that it's not ramped up. There are internal tools at Microsoft that you can run host tests that will give you all the data, internal data, but it's not available to customers. It's only available internal to support. And I was customer success, so we had it. We could run these tests and see it and find out, but you just got to verify and make sure that you've got that. And then configure huge pages, which of course we love. Make sure that you've configured this. This of course will give you better performance on the IO. And then change the limits on the file for our memory. And you've got to, of course, run syscontrol.p to set this. And what did I get from this? I ran my tests again, and I got a 35% improvement in the performance. I felt that it was definitely worth it. I got hit by the Google people for the synchronous commit being off. They asked me to turn that back on and do the test again. But this was my best number, and they were happy with this. They were happy with this. It was only one person off of Kevin's team that complained about it, and they overruled him. So I did win this battle, but because they said they wanted performance, they want to know what I could get in performance. Nobody gave me any, again, no rules, no rules. But you can see the numbers and what we ended up getting to, which was much better than Premium Disk, Silk by itself, and then Silk with parameter changes.
Do you know what it would have been if you made all the other changes except for the
129.
129.
Yeah. it was a worthwhile change in it. I lost 10,000 on that, I think. Or 100,000. Yeah, I don't know. Gotta look at my number and come back. Yeah, 10,000. So, but I also use database views to look at some of this because I was just curious. I know what I would look at if I was in Oracle, but I was curious how to do a lot of this in Postgres. There's a friend of mine that worked in Postgres for a very, very long time, and he just didn't feel that a lot of the view data was there, and he had challenges. And I know he had asked a number of us, hey, does anybody know how to do this? So I wanted to see what was there. I did have some data that was cached, which made me a little concerned. I do have the links on what these views were. PG stat activity. This helped me get some of the OS level information so I could get a little bit better picture. I did, in the very end, my latest test, I'm using Redgate Monitor as well. I'm helping test that out because we're newer to the PostgreSQL monitoring. So I grabbed that, and I also use check Postgres to actually look at it as well. But I didn't feel it gave me a full picture. Please.
So at the PGConf Dev this year, we were having a session where we actually talked about that back-end memory use. And some of my issue here about it. And so then you all
Oh, excellent.
because I'm running into cases. I'm running a single lecture puller and not getting recycled.
It was getting OOMs, wasn't it? Yeah, that's terrifying.
So limit our connection puller. And so they're going to do that. So the connection puller is going to be used to return and oh, it's over so much. Let's close that connection and open a new one.
Interesting. I think because I wasn't doing a lot with connection pooling or anything, I did not run into that. But it's good to know if any of you are, be aware of that. PG stat wall. It's just a select star from this is all I was grabbing. But it gave me, of course, the right ahead log records, FPI, bytes. Of course, I'm all about the bytes. And I think I would end up almost grabbing this and going, times 1024 or divided by 1024. I want to see the megabytes on that, even though it was going to be small. It's just a more controllable number. But I think it gives pretty good information off of it. And then PG stat IO. The reads on here, pretty clear, writes. This is a small value that you're seeing on this. When I got into the workloads, they were much larger. I just grabbed this so you could see the output from it from my Postgres database that I have running locally. But just grabbed it in here where reads were not zero and not extends. This is not zero. And then monitor the shared buffer evictions. This was one of the things that's almost a configuration on this where what it was configured to. And understanding that it filled, then evictions actually occurred. And I just used the PG buffer cache extension to monitor it. And then looking at the maintenance here, I was looking at this one as I grabbed some of this data here of figuring out when my vacuums were happening. I'd found out that I had a little bit of a performance hit on the system when auto vacuum was on. And I first shut it off, and I go into this a little later where I say actually leave auto vacuum on. Don't let manual vacuums happen. Those will cause more of a performance problem. So I did wrong when I first was starting out and was shutting off auto vacuum was to, don't do that. Don't do that. But this is a good way to monitor those too. And PG stat database will tell you your cache hit ratio, commit ratio, database outliers, load distribution. This is all available in there. And this is going to look like this. So I can see each one of my databases with my cache hit ratio along with the other columns if I want. Yeah.
Isn't it the problem that once you turn off the vacuum, therefore, yeah,
Because it's in movement.
What to do.
Yeah. Yeah, I definitely felt that way. I didn't get into it too deeply, but what I assumed, and I see this from, a database point of view, as a multi-platform person, of seeing it that, you know, that your database is in movement. You're doing these transactions and it's changing constantly, and vacuum just says, oh, I need to update again. I need to update it. I need to update it. And if you issued it manually, it seemed to have more of a problem with it than if it was the auto vacuum, where it was like, I need to do a sample and just stop. I need to do a sample, stop. And it seemed to be a smaller amount than if it was a manual vacuum.
Yeah, what do you think? Yeah, well, I think they'll- But if you.
Yeah, the recommended practice after I did research told me leave my auto vacuum on though.
Was that mistake for? Browser created or make it? Would you have to maybe?
It was a generic recommendation. It did not determine between TBCC and TBCH. So I just left auto vacuum on all of my tests after that. Because I did have challenges with it. I did. And it again kind of comes back to my Oracle history, where if you were trying to do all these inserts, you're building a workload, these warehouses and all of this, and statistics come in and they start writing it, it can go awry because it's like, it's still changing and I've got the wrong numbers. Now, you know, it's now stale. I need to go do it again. And you end up with this perpetual sampling that happens in that. So I did not want it touching it at all. But then I found out that was not the right way of doing it. Please. Say that again. It doesn't have auto vacuum. It has auto statistics and they're usually turned on. And as of 11.204, they ended up doing something called dynamic sampling. And dynamic sampling can really come back to hit you in really very large databases. Let's say you've got a 1.2 terabyte table and somebody's doing a whole bunch of changes to that table. And it comes in and says, my stats are stale. I think they're stale. Oracle, the optimizer, has a mind of its own. And it says, I think they're stale. I'm going to go in and sample this table. So you may have a query that takes 1.2 minutes to run, and it just spent another 8 minutes doing a sample on it. So you have to explain to somebody where that 8 minutes went. And I'm sure you've run into that, Jeremy, and not fun.
Another difference. What we call two jobs. One of them is the statistics, and one is the parallel. The second job that is sort of the equivalent of undo an Oracle or the MVC. That is very unique to Postgres. That is different from SQL Server, MySQL, Oracle, everything. They all work very differently with Postgres, and none of them have a job that's equivalent to them. So the MVCC part of vacuum that like sort of cleans up.
I was surprised how much it does, because again, my history goes back to Ingress, where it was very much in its infancy. And I just remember the write ahead log and the before image and the after image stuff we would get. And it just was so different how much it's evolved.
Jeremy, the third thing is it adjusts the visibility.
Yeah.
There's the third.
Then, yeah, yes. In the freeze map, there's a couple like little things in there as well. Yeah.
So we had different miscellaneous views. We kind of went over this before. These are just the other ones that are available as well for indexing, as well as, PG, stat IO, all tables in that. Miscellaneous views, the one thing that I found is that I like the IO information in it, but if a PG stat reset was performed, which I find out it is doing in HammerDB after it, data may be inaccurate. So that surprised me, as I thought I would get this and that, oh, it must have the historical data in there. It is running in the version that I was playing around with. PG stat reset is part of the HammerDB run. Very much surprised me. And there we go, vacuum. Yes. Disable both checkpoint and vacuum job as part of the test. As you may experience long waits, auto vacuum during test is less impactful. This was the exact recommendation that I pulled from the web that they said for best practices from HammerDB for PostgreSQL. They said to leave auto vacuum on.
Did you try the
I did not go that far. And I think This is still kind of an ongoing project. I know how the company that I'm still working for 4 hours a week, so they'll come back and all of a sudden they'll be like, yeah, Google's back. We want to do some more. So I shouldn't say that it's over. It's never over for me. Yeah, it can come back. Yeah.
And do you find that with the increase in network attached storage, and just the difference in assumption that used to be with spinning disks and now we have today, does it make a difference with different settings for dirty buffer rates?
I tried to use something effective IO. There's a setting.
Yeah, you can concurrent.
Yes. I tried to work with that and I could not get any performance gain out of it, let alone sometimes it wouldn't even start on AlloyDB Omni. Database would not start with that parameter.
I was thinking more like the checkpoint targeting, like for like the background dirty buffer rates. The goal of that, right, is to avoid much of random writes and checkpoint. But if they don't matter as much anymore, maybe it doesn't.
Alloy might not have checkpoints.
And I don't think, well, it does in AlloyDB Omni. It doesn't in AlloyDB. Yes. Now, I had this conversation with Bjorn and we were just geeking out one day and talking about it. And I have to admit, that's one thing that I know is that he says, well, with Omni, you do have the checkpoints and we don't have that because the way that it's written. And he didn't go into details with it. I don't think he could share it with me, but I will tell you that AlloyDB does not need it because of the way that it is designed for the past solution. But AlloyDB Omni is a little bit different animal. I think that probably makes more sense to you than me because of your time at AWS. Yeah, I had a feeling. So yeah. So yeah, these, I think we got most of all this. We're doing pretty good here. I avoided doing the manual vacuums during the benchmark tests, completed the views and weights can be found in the pgstat.io. I was able to pull this data and I kept retaining it. I'd grab the data and put it into my OneNote. I use OneNote for everything and just broke it all down into each of my tests. And then we got into scaling. So one of the things that they wanted was to find out what happens when you go from 16 vCPU to 32. I was seeing that I was hitting a ceiling at 16. So what would happen when I doubled this? So I couldn't get much more out of it. Get a little bit more, but not a lot. My network attached storage, I was barely touching it. And I knew that. And a lot of times, the SILT people are like, come on, really pick that thing. I mean, get some performance out of it. And I had all these numbers. I mean, the ones that you're seeing for Cosmos DB, the Citus, 1,000 with 1,000 users, 1,000 warehouse, single node. AlloyDB with Silk, 1,000 users, 1,000. You can see, I mean, I was getting some really good performance versus what they had published. And again, at the end of here, I have the links to all of those benchmark tests that were already published by GigaComp. They already published them. These are real numbers on these other flavors. Cockroach, Yugabyte. This is for single node, what they were getting for this. So they were like, can you get more? Can you get some more, performance out of this? Because this doesn't look good and those look horrible. I mean, Google loved this. Can you get inch more out of this? The problem is I couldn't. I started doubling this, 16, 32, 64. My performance actually went down. All optimized parameters. Again, I started looking at, the concurrent IO parameters. There were a couple other ones that I tested out. I couldn't inch anything more out of this. And then I went back and I said, I failed you guys. I can't get any more out. And then they admitted to me, neither could they. They were in the same boat. They were like, we just thought maybe you'd figure something out. I'm like, I didn't. I got stuck. You could see I got a little bit more, but not much. The numbers never really increased. So this is where my knee was. And I had to come back to him and go, I got worse numbers. And it didn't matter if I was on Google, didn't matter if I was in Azure with VMs, didn't matter if I used, I kept up in my C nodes, in my Silk data pod. I kept trying to do everything. Didn't get that much. Please.
I love that. Just had it.
Yeah.
Because This is like such a, so this happens all the time with people's real world applications where they think, oh, my application's slow, I'll add more CPU and it'll go faster. And then it can go slower when you have, and like people, like we've been talking about this for decades because this is not new. It's not unique to this.
And virtualization does not help with this either. I wanted some of my host level reports off of Azure. I didn't have access to those anymore because that not only will identify VM bottlenecks, it will go all the way down to the host, the underlying host that VM resides on. And I miss those. Have you seen these? Because you're like sitting there going, uh-huh. Yeah. And I can't see any of that. And I'm like, there's a bottleneck happening somewhere and I can't identify it. And then when I was inside the container, I mean, I'm pretty good with Docker and Kubernetes as they were throwing these different ones and making changes to it. But, you know, I was hitting up my friends. I've got a couple friends that work with VMware. I mean, they do changes for VMware for them. And I'm like, what am I missing? What am I not seeing here? And they'd look at this and go, who designed this? And I'm like, David, and Rick left. He'd know David Clee. David Clee's like, this is the biggest piece of junk I've ever seen in my life. And I'm like, don't tell me that. I need to be able to figure it out. But there was so much virtualization, it was hard to tell where anything was coming from. And part of you almost says, this is a database as much as we want to containerize it. You've added all this additional complexity that makes it hard to troubleshoot it. So that really bothered me. That really did as I was going through all of this. So here's where we go next. Here's my single note. I'm barely hitting 5% on this. This is with FIO. This is what I got with FIO. Here's my 16.6. These are my recent tests that I did this summer. 16.6, 17.2. That's the 15.1 that I had gotten on here. I knew with FIO, that was my numbers. That's what I could get. Then I went multi-node. I had a 61% utilization of Silk. So I took multi PostgreSQL databases and all connected them onto the same Silk data pod. They're all running their own HammerDB tests. They're all running at the same time. And it went zoom, but they're all 16 vCPU. Then I could use the storage. Then I could use IO. I could use multiple databases. Excuse me. So I knew it wasn't a Silk problem. This is just throttling at the PostgreSQL. LIDB, same thing, 285% increase from single node. Yugabyte and Citus, they already had the numbers. They already were doing 7,600. I mean, LIDB and Yugabyte, right exactly the same. I mean, they were within just a couple megs of each other. And then Citus was a little bit farther behind it, but I think I told you Hyperscale can do about 300 megs per second per cluster. So you start per node, you start pulling it up 16 minutes at each. But I could really get some good performance when I went that way. So this is what I started playing around. I started distributing this across PG Edge, and that was that next test. I did have multiple databases, and then this one here, I did distributed. So I grabbed PG Edge because this is the way that I just found it online. This is what happens with me, yeah. So you know I do a lot with Oracle, globally distributed. And the thing is with that, that's the future of Oracle. Rack going away, data guards going away. It's going to be all globally distributed because that's actually cloud savvy. It will replace everything. This idea that you can auto key and everything else, your sharded keys are all auto. So I was like, why don't I play around with this one and see if I can shard the database and start hitting it? So I did that as my last test. I thought this was the first one. Thank you for pointing out my left side blind spot. So ended up with utilizing again Silk though. I was getting the performance. I knew it could get it. It just can't do it without being clustered, without being multi-node. You just hit that ceiling, that knee at about 16 vCPU, maybe 18 vCPU, where it just seems to limit and throttle. And I don't know if anybody in this room feels that they are getting more out of Postgres. Because that's where I kept hitting it. And that's where the Google guys said, yeah, we're having the same problem. Please.
Are you saying that you expect a single Postgres, but they're partitioning it different? They're sharing the same storage bank?
Storage.
So would you be able to use 50% of your storage bank?
Yes.
And how many nodes was that?
This one here, I put 4.
So each one was able to use like 50%.
Yeah.
But a single one was only able to use like 6.
That's all I got it. But I was also learning as I went along. Remember, this is a moving target. This one here is, I want to say I was doing 17.1 with PG Edge and playing around with this one. I'd have to go back and look at all my notes and everything on the flavor of this one and what I was doing, but it was just standard Postgres. That is an Alloy DB. But I just was curious what it would do if I started doing some kind of cluster, some kind of sharded system, try to do multi-node. And they already had these numbers. This one we did. They went and ran it for me. And we put Silk underneath it.
And I'm sorry, it's Silk is.
Silk is, it's VMs clustered into a Kubernetes data pod, and we're using the NVMe on it to give high I/O. And it's network
So you build-
attached.
You build your own.
Yep.
Silk is providing basically block storage. So you're just mounting your block storage for Silk. It's better.
But you can do it on Google too. But we got much better performance when we were able to use a clustered environment. And the goal of this was, Silk was hoping that Google might go, well, that's cheaper than Hyperdisk. Maybe we'll put that under it. It didn't happen, but we got to test it at least. So makes sense where I went there, even if I didn't get the results that I was hoping for. So in summary, what I ended up with is, yeah, HammerDB, it gives you performance data. Gave me some information and opportunities to improve, but I definitely had to use other information to kind of feed into it and figure out what I needed. PostgreSQL really seemed to throttle at about 16 vCPU, 18 vCPU, if we be honest with it. But when we start looking at VMs and machines, what they're coming in with the CPUs, most of the time you don't get, well, if you can choose, but most of the time you're getting a pretty straight number, 8, 16, 32. The recommendations, what I've got here, you could do this in your own environment. Any of those that look interesting to you that you think is acceptable, that is safe for your environment to run, those are all recommended practices that I found out there doing research and checking them all out. And those slides are available to everyone. I'm glad to share them. And with that, any questions? And also, here's all those links to all of those stories with all of the data. Like I said, those links will be, I'll share the slides and everything so you can click on them and go to the stories, because there's one YouTube video and there's a whole bunch of information out there. Please.
So did you ever find your
Did I find my what?
the bottleneck that was getting as the
No, I never could. I mean, we would see that it was throttled at 16, but at 32, it'd just go up to about 18 and it would never do it anymore. It would never go any farther. To me, I can see those limitations in just how the update to the CF table was constant. To me, I wanted to optimize that. Could I partition that table? Could I do something more optimally in Postgres with the index? But I didn't feel I had that level of knowledge that I needed in that database platform to really go somewhere with it. At the same time, I'm changing that database. I'm changing that design, which is a little bit, it takes away from that apples to apples.
For what it's worth, we right, it's some 16, some 32, some higher, and let's before whatever, and we scale just fine. But don't
Yeah.
virtualized. Well,
And I think that's part of the problem is the virtualization. I had the same problem in Postgres stuff, that I get up to about that 18 vCPU and it doesn't seem to be going any farther. But all of those workloads, all of it, every single one of them is running HammerDB. It's not running any other workloads than HammerDB. And for me, everything that I was seeing, it had to do with the database design and the SQL that it is running, that it was all in that update statement all the way through.
Yeah, this goes very beginning. I thought what you were saying. HammerDB. Yeah, so many things are workload. So certainly some workloads will scale beyond 16 CPUs.
In Oracle, I could have told you exactly what was going on. I mean, even in Slob, we see that. We know exactly what's causing it when we hit that limit, that ceiling. And even Kevin Clausen, who wrote Slob, has come out with more efficient ways. Oh, you want to do a high I/O workload? Run this test in Slob instead. We don't really have that. I mean, we've got the TPC and TPCC and the TPCH, but
Kevin has published a Postgres version.
has he? And I'm surprised that,
Oh,
I shouldn't
yeah.
be surprised at that, I should say. I was gonna say, I'm surprised it took them so long, but I hadn't even looked at it.
There is a slot. for-
There's my next test. Will my slob.conf work?
I don't know, actually.
That's the next question too. Yeah, do I just need a few changes to my preferred slob test? That would be fun too. Okay. There you go. Next test.
The development. That's what we do. Mention about sequential commits. That's something to do also with the exception. That's. Or is it something different?
In Postgres,
Synchronous.
synchronous. Yeah.
I'm a little confused about what is that comparison.
Async versus sync commits. When we start thinking about that, it has to come back and verify that everything has been written to the disk before it's going to let it go. That's the way that I would kind of put it into layman's terms. Versus async where it says, go ahead, at some point it's going to commit. We're good.
So you were
It's-
running in synchronous.
Yes. And saying, just shut it off. Don't even wait for it. Just keep going. Run the next, keep going.
So you were asynchronous.
It's a data loss.
Yeah.
So it's-
And you
it's-
could lose transactions.
Yes, you can lose it. So what it has to do with the commits. So normally, if you want to be safe, so the way databases work, your transactions, most powerful features of relational databases. It's this idea like you have a group of work that's sort of an atomic unit that you either.
That's what you guys mentioned.
So normally, when you're doing work inside a transaction, like you don't need to wait. Like it can all, you can send off some work to the database. It can just go in the background, your application keeps going. The moment it doesn't really matter because until you commit, like there's nobody who's made any kind of a promise that that data is durable. And there's also the word durability is a big keyword here.
Yeah.
Commit is the keyword. When you say commit, that's your request to the database to say, make this durable. And at this point, I want you to guarantee to me that I will not lose the data anyway. If the data center goes up in flames. I
But that's
know that
when
I can
local
lose the data.
versus having standbys, because you can have standbys and it goes until it comes back from the standby and says it's committed this, don't release it.
Yeah,
Make
so
sure everything's
normally,
good.
when you say commit, it will not return a success message on your commit statement until the data is on the disk, stored on the disk. So
Which
that
is
if the
local.
server crashes, it's not lost. This setting, what this setting does is if you flip this, it'll say it doesn't need to be on the disk. I'll go ahead and return, I've
Success.
got it on the server in memory. So I'll go ahead and return it successfully. Now, if you get a server crash right after your commit, like it might not make it to the disk. And that's what the setting does. So you have the potential of a crash at the right moment, could be a little bit of data loss. Could lose, whatever was in memory and had gone down to the disk. But you can get more performance, more juice out of the system this way for a test.
And
Yes.
another second lets you tell how many milliseconds you want to delay for. So we use that for a queue server, and it makes a big difference because we're writing all the time. And if it loses a few things, it's no big deal. But you can say, like, I'm good for 30 milliseconds worth of asynchronous.
Or if you have batch loads that you could rerun and you're like, just get it in there as fast as you can. I don't care if it's, kind of come back and said it's all right.
Yep.
Yeah. Yeah. But of course, Google had issues with that.
This phenomenon is used for other software. also.
Yeah.
If you need the right.
Excellent.
Good topic, good question. Any more questions before we wrap it up?
Jeremy?
When you said that you were seeing some update statements, did you happen to see anything in the wait event tables for Postgres?
I don't remember such. I'd have to go back and check. I did these tests in between everything else. I built out products in Fabric and Microsoft and AI products, everything. I mean, that I remember this amount is pretty amazing. I'm actually impressed that I just wrote this and it actually came together. But I would say I need to go back and check. I agree. To me, it was in either the SQL or it was in the database design, and that's where I needed to focus. And to me, I felt like that would be changing the actual HammerDB test, and I wasn't going to go there. And I also work with all storage guys when I'm at Silk, and all they want to know is the storage configured right? It's storage, isn't it? Something's wrong with the Silk data pod. And it's like, guys, you're fine. I did the FIO test. You're good. Because they're always going, I know it was so-and-so. He didn't install that right. It's fine. Everything's fine, you know? So there were always those challenges as well, where I was like, I'm not seeing it there. I think it's in the database design. So we would come back and everything would be on fire one day where everybody wanted answers. And then they'd go away again for 3 months and want me to work on something else. So yeah, that's kind of how this came about.
This really makes me think of using a lot of people.
Again, I would say that we're changing the HammerDB test. And to me, it's like, what is the goal of this? They wanted to see what we could get in performance, and I go back and forth. If I would prefer actually doing slop. That is a good idea, though. That is a good idea to find that. I won't lie to you, using slob is where I want to go naturally because I know slob so well. You know, I've got so much history in Oracle that I'm like all about going, I'm downloading that tomorrow. It's going in. Yeah. Because I know exactly those statements. I know exactly where I'm going to have my performance bottleneck. If I see it, I know what's going on. I know what's going on. And I can't say that for HammerDB.
Like the whole sort of. Like what are the rules exactly? It's the fact like how you know your rules, like what you're trying.
Yeah.
Between running a test for marketing purposes versus you might be running a test because you want to do an internal study to find out where bottlenecks are, you know, where to spend your development for the next 6 months. So there's or to understand certain workloads, or making a purchase decision. That's another reason you might want to run a test. So you're a company who's going to purchase a product and you want to do just sort of your own in-house bake-off. So in that case, like the goal there would be to understand the products well enough and configure them the way you're going to run your own application, like as close as possible to that.
Well, that's where we get into products like real application testing called RAT inside Oracle. This becomes a project under itself, and it actually does a recording of everything that you run inside your production system. You're supposed to be able to lift, shift it, put it into another system and do your performance test and go, this runs just like it did in production. There you go. It looks like the workload, everything. But it becomes a project in itself. It can go on for months. And so anytime somebody says, oh, we'll just use RAT, everybody runs like rats. I mean, it's terrifying. So you have to think about that. What is it you want to achieve and what's the easiest way to do it? So most people end up bringing out usually FIO or HammerDB or slob, and then they go, here's our top 10 reports, our top 10 SQL statements that we run in transactional purposes that we want to run and see what the performance is on this new system and say, we're good. That's usually what ends up happening. And that's how I did it for Microsoft, is we were moving these monster systems into Azure. For me, when I was there, it wasn't just Oracle. I did MySQL, I did DB2, anything no one wanted to look at that was really big, that's the ones I usually got. So that was usually the win. Anything else?
Those questions are also why you want us. So there's always going to be the better claims. People will say, benchmark your own system.
So can we talk about IOPS? It's the biggest bunch of BS on the planet. let's be honest. What is a request and how big is a request in different systems? Oracle is incredibly efficient with request size. So when somebody says, well, I can do 300,000 IOPS, and I'm like, that's really nice, but Oracle come back and look at the workload. Oh, this is 30,000. This is easy. And it's doing 37,000 megs per second. They don't realize that it's efficient on IOPS. It could kill you.
There's total. So like if you're measuring the number of say from Linux, like /proc, you might get one number, and then you go to CloudWatch and you look at your IO, and you see a different number.
Yeah.
The reason is because like IOs, like what happened was the operating system got two IOs, and then like the firmware sitting on the dongle like coalesced those into a single IO. But it didn't count as two IOs, like for purposes of accounting and whatever kind of throttling or performance that they do, to, like guarantee performance.
That's why I'm like, give me throughput or we have nothing to talk about. I want real numbers.
It's fun. Cool. Well, thank you very much, Kellyn.
Thank you.